Introduction to de Broglie relationship. We know that, during the 20th century, scientists discovered that light exhibits both particle and wave nature. And it was Louis de Broglie who introduced the idea that matter, such as electrons, can also exhibit particle and wave nature. He discovered this by passing a stream of electrons. The electrons get reflected when they hit against a crystal, and spread out when they hit a thin metal foil. This explained the duality of matter, and on the basis of his observation, he derived a relationship between wavelength and momentum of matter. Let us learn more about the de Broglie relationship. At the end of this lesson, you will be able to define de Broglie relationship and solve problems based on the de Broglie relationship. Applications of de Broglie relationship. An electron microscope is a powerful tool in modern scientific research that achieves a magnification of about 15 million times, using the wave-like behavior of electrons. De Broglie relationship. De Broglie equation relates a moving particle's wavelength with its momentum. According to de Broglie, wavelength lambda is associated with a massive particle, and is related to its momentum p, through the Planck's constant, h. Therefore, wavelength lambda of a particle with mass m, and velocity u, is given by the relation lambda, is equal to, h by mu, where, h is the Planck's constant. Considering the wave nature, Planck's equation is given as, E is equal to hv. Let us assume this as equation 1, where, E is the energy, h is the Planck's constant, and v is the frequency. Considering the particle nature, the Einstein equation is given as, E is equal to mc square. Let us assume this as equation 2, where, E is the energy, m is the mass, and c is the speed of light. Combining equations 1 and 2, we get hv by c is equal to mc. Let us assume this as equation 3, where frequency v can be expressed in terms of wavelength. Therefore, we get 1 by lambda is equal to v by c. Substituting values in equation 3, we get h by lambda is equal to mc. Therefore, lambda is equal to h by mc. According to de Broglie, this equation can also be applied to the matter, by substituting the mass of the particle m, and its velocity u, in place of the velocity of light c. The equation thus obtained is the de Broglie equation, and the wavelength is called the de Broglie wavelength. This equation can also be written as, lambda is equal to h by p. Thus, the significance of the de Broglie equation lies in the fact that it relates the particle character to the wave character of matter. Problems based on the de Broglie relationship. Problem 1. What will be the wavelength of a ball of mass, 0.1 kilogram, moving with a velocity of 10 meters per second? Solution. According to de Broglie equation, lambda is equal to h by mu. We know that h is equal to 6.626 into 10 power minus 34 joules second. After substituting the values, we get lambda is equal to 6.626 into 10 power minus 34 meters. Let us move on to the next problem. The mass of an electron is 9.1 into 10 power minus 31 kilograms. If its kinetic energy is 3 into 10 power minus 25 joules, calculate its wavelength. Solution. Kinetic energy is equal to 1 by 2 mv square. V is equal to 2 into kinetic energy by m, whole power half. After substituting the values, we get V is equal to 812 meters per second. Then applying the values in equation lambda, equal to h by mv, we get 896.7 nanometers. Now let us see another problem. Calculate the mass of a photon, with a wavelength of 3.6 angstroms. Solution. Lambda is equal to 3.6 angstroms, which is equal to 3.6 into 10 power minus 10 meters. We know that the velocity of a photon is equal to the velocity of light, where m is equal to h by lambda v. Substituting the values, we get 6.135 into 10 power minus 29 kilograms. Conclusion. Thus, we can conclude that the de Broglie equation relates the particle character to the wave character of matter. Summary: from this lesson, you have learned that the de Broglie equation relates a moving particle's wavelength with its momentum, with the equation lambda is equal to h by mu.